So this section is 1.1 lines in the plane. It's going to be talking about creating equations of lines, something that you have done in Algebra 1 and Algebra 2, so it should be a little bit of a review. So we're going to start with the slope of a line, which is the steepness of a line. So the ratio of the vertical change to the horizontal change. And that part of the definition is talking about this formula. So M is always the letter we use for slope. And it'll equal, this little symbol means the change in y over the change in x. So to find that change, we subtract the two y values and then subtract the two x values. And you want to make sure that for the two different points, this is one point and this is another point. So it doesn't necessarily matter which one is 1 and 2, but you do want above and below to match. So taking a look down at the bottom, this line is representing a line of positive slope. This line going down is negative slope. The line in, that's horizontal completely is a zero slope, and the completely vertical line is an undefined slope. So that's what those would look like visually. So I have a little slope tree. You can see going up positive, down negative, horizontal is your 0, and then the stem of the tree is a vertical line, which is your undefined. So just a little something to help you remember. So we have an example to find the slope of a line passing through each pair of points. So in order to do this, we're given 2 points and we're giving the formula. So we're going to plug into the formula. Keep in mind that it doesn't matter which one is x1 and y1 and which one is x2 and y2, as long as you keep the pairs above and below each other. So I'm going to start. I'm going to start by making this point x1 and y1 and this point x2 and y2. But like I said, it doesn't matter which one you pick. You do, however, want the first number always to be your x and the second number to always be your y. So now if I plug it into the formula, I get 1 minus 0 over 3 minus negative 2. So 1 minus 0 gives me 1, 3 minus a negative, so a double negative becomes plus. So for number 1, my slope would be 1/5. Taking a look at example 2, I'm going to switch it up. So now I'm going to make this my x2, y2, and this my x1, y1. So if this is x2 and y2, my y2 would be 2, and then my y1 would be also 2. My x2 would be negative 1, and my x1 would be 2. So now simplifying on top, 2 minus 2 is 0 over negative 1 minus negative 2 is negative 3. So 0 over negative 3 gives me 0. So 0 divided by any number will always be 0. Keep in mind, though, if this 0 was on the bottom, that would be undefined, not 0. All right. And then our last example, number 3. So we'll go back. We'll say this is x1, y1. This is x2, y2. So negative 1 minus 4 over 1 minus 0. On top, we get negative 5 over 1, which would be a slope of negative 5. So we have 1/5, 0, and negative 5 as our answers. So now we're going to take a look at different equations of lines, starting off first with our general form. So in the general form, you want to take everything and move it to one side. So as you can see, everything's over on the left side here and set it equal to 0. So we have 2 different examples of how you can do this. So first, maybe it's 2x plus 3y plus 1 equals 0. In that case, we have an A, B, and C. In this case, this is still considered general form because everything's on one side. But in this case, our C is 0, so you don't have the plus, just a regular number on the end there. The next type of equation of a line is a vertical line. So this will always be an x equals something equation. So an example of that would be something like x equals 2. You could have x equals any number. And an x equals equation, the vertical line, it goes up and down, it has that undefined slope. Our third type of equation of a line is a horizontal line, which is a y equals equation. Y equals b could be y equals 1, y equals 3, y equals 100. So any y equals equation gives you a horizontal line. Keep in mind, though, this y equals, it doesn't have an x anywhere in here. So it's just y equals a number. Then we have the slope-intercept form. This one is really most commonly used, y equals mx plus b. So m is always our slope, b is always our intercept, our y-intercept. And so an example, you could have y equals 2x plus 4. And lastly, point slope form. So this one we'll use a lot when creating equations. We'll start out in point slope form, so it's good to know it. So an example might look like this. However, you probably wouldn't leave it like that. You might want to put it into slope intercept form or general form, but it's a good place to start. So here's an example, point slope form of an equation of a line. So find an equation of a line that passes through the point 1, -2, and has a slope of 3. So to start, we would plug into this form. So like I said, this form is great for plugging in when you have a point and a slope. So, looking at the name of the form, point slope, that's what we're given. So that's the form we'll start in. So 1 minus -2 equals 3 times x minus 1 is how you would plug that in. And then to simplify, the double negative becomes plus, and then you can distribute the 3 if you feel like it. You wouldn't necessarily have to. In this example, slope-intercept form, so determine the slope and y-intercept of each linear equation, then describe its graph. So if we want to know the slope and y-intercept, we probably want to put it into slope-intercept form, which is our y equals mx plus b. So thinking about this, it's essentially solving for y, because you want y on one side of the equation. So looking at our first equation, y is not alone. We have this x plus in front. So our first step is to subtract x to the other side. So now we have y equals -x plus 2. Y is finally alone on this side, and so now it's in slope-intercept form. So in this case, our m is -1, so slope always comes whatever number is in front of x. Since there's not actually a number there, 1 is the placeholder, and b, our y-intercept, is always whatever is added or subtracted on the end of the equation. This one is already solved for y. We have y equals 2. It's a little bit tricky. This is a horizontal line, so you can either think about it going back to when we were talking about slope with horizontal lines, or you can also think about it algebraically. So if we were to write this out, algebraically, this is what it would look like unsimplified. So y equals 0x plus 2, because 0 times anything times x is going to give you 0, which would result in it just simplifying to 2. So here, our slope is 0 and our y-intercept is. This example, find an equation of a line that passes through the point and has a slope of 3, right in slope-intercept form. So we want to start out by putting this into point slope form because we're given a point and we're given a slope. So there, point slope form, and then we simplify. So double negative becomes plus, and we distribute the 3. And since we want to write it in slope-intercept form, our last step is to solve for y. We want to move everything over to one side and have y on the other. And so when we subtract 2 from both sides, we get y equals 3x minus 5. Keep in mind, you only subtract it from the like term. So -2 would only subtract from the -3, not from 3x, because an x and a number don't subtract from each other. If we wanted to write this in general form, so it's still the same information, the point is 1, -2, and it has a slope of 3. So this was our slope-intercept form of the equation. So if we wanted to write this in general form, we want to move everything over to one side, which would look like this. We could subtract the y over, everything's on one side, it equals 0. Another way to write this is moving everything over to the left side, and we would get -3x plus y plus 5 equals 0. These are both correct. The signs are completely opposite, and that's actually what will happen depending which side you move it to, but both are considered correct. And then lastly is parallel lines. So parallel lines are two distinct lines with the same slope. So whatever your slope of your first line is will equal the slope of the second. So find the slope-intercept form of the equation of the line that passes through the point 2, 1 and is parallel to the line 2x minus 3y equals 5. First thing we do is we find the slope of this line, because if we are parallel to this line, we want to have the same slope. So to do this, we're going to start by putting it into slope-intercept form, solving for y. So first we'll start by subtracting 2x to the other side, and then dividing by -3 all the way across. And this is the slope-intercept equation we get, which means our slope is 2/3. So since the slope of this line is 2/3, we want our slope of our new line to also be 2/3. Now that we found the slope, we want to use that slope to create an equation with this given point. So we're going to treat it as like we're doing a point slope, finding a point slope equation. So here I have my point 2, 1. My slope is 2/3 because our line is parallel to that other line that they gave us. And I'm going to put it into the point slope equation because that's the information we have. So y minus 1 equals 2/3 x minus 2. And now here I'm going to distribute the 2/3. We get y minus 1 equals 2/3 x minus 4/3. So keep in mind when we're multiplying fractions, so 2/3 times 2, like 2/3 times 2/1, so 2 times 2 gave me 4. 3 times 1 gave me this 3. So I know we're working with fractions here. This is getting a little bit confusing, but just bear with me. And then lastly, so we want to get y alone. The last thing we have to do is add 1 to both sides. And now we're saying, how do we add 1 to -4/3? Well, if you remember, I'm going to put it over here. When we add fractions, we need a common denominator. In this case, it would be 3. So if we multiply 1/1 by 3/3, we get -4/3 plus 3/3, which equals -1/3. And so now we have our equation of our line. So let's look at perpendicular lines, two lines with opposite reciprocal slopes. So they're not the same slope like parallel, they're opposite reciprocal. And so if we think about finding the equation or finding the slope-intercept form of an equation of a line that passes through the point 2, 1 and is perpendicular to that line, this is the same information we were given before. So we know our slope is 2/3. So the first thing we would want to do is find the opposite reciprocal slope with the given point. So here, just ignore this stuff. So here we have the slope of -3/2 because the opposite reciprocal of 2/3 would be to flip it and make it negative. And so then we would distribute, we get -3/2x plus 6/2. Keep in mind this is like 2/1, so you multiply across the top and bottom. And then we get y minus 1 equals -2/3 plus 3. And then our final equation, we would want to add 1 to both sides. So lastly, final equation would be y equals -3/2 plus 4.